which ones you have questions with? 4D. Does that go? State two conditions that must be satisfied for a copper wire that's placed in a magnetic field to experience a magnetic force. There must be current through it, and the other one is that the current through it must be what to the magnetic field? Perpendicular. Okay. Normally there should be a current and there should be some angle. Fully perpendicular, you get the maximum, but you could say the other argument, which I feel is more appropriate. It can't be parallel. Okay, because perpendicular now will force hoy. It's just parallel to the force hoy na. Okay. A long air cored solenoid. So what's an air cored solenoid? So typically solenoids have what inside it? Iron, right? But what if there's nothing inside the core? Will it be a solenoid? Like there's nothing inside the core, it's just a coil. Will it be an electromagnet? Yes, absolutely. It'll be completely normal, nothing wrong about it. It's just that we place the iron core inside to make it a what magnet? Stronger. So the placement of a core is not a mandatory requirement. It's just an improvement. Okay. So there's this air cored solenoid that's connected to a power supply, and so the solenoid creates a magnetic field. 6.1 shows a cross section through the middle of the solenoid. The direction of the magnetic field at point W is indicated here. 3 other points are labeled X, Y, Z. On figure 6.1, draw arrows to indicate the direction of magnetic field for each of the points X, Y, Z, and compare the magnitude of the flux. Okay, so our magnetic field lines গুলো এদিকে যাচ্ছে। এটা একটু দেখাই কেমনে করতে হয়। This could have been an O-level question. O-level এরকম জিজ্ঞেস করে না, but O-level সেটা possible. So all the field lines should be like this. So if I look at this edge of my solenoid, right, field lines are coming out from it. And if I look at this edge of my solenoid, field lines ki korteche, enter korteche. So I can say that the left-hand side will induce what kind of a pole here? A north pole, because a north pole, the definition of a place where the field lines emerge from, right? And this is going to be your south pole on this side. So you said a south pole thakbe. For that to happen, how should the current have to be in the coil? So current চাইনি মনে হয় এখানে চাইছে কোন জায়গায় আচ্ছা দরকার নেই but we could find the current as well because you know the right hand rule. So এটা যদি নর্থ হয় আমার সামনে দিয়ে উঠবে পিছনে নামবে. So these should be all what? Dots. You know, because current is coming out from here and পিছেগুলো কি হবে? Cross, because current is going into it. Are you able to visualize what's going on here? Right. Okay. Now, how should the field lines look at Y and Z? So how does the field line look like around the solenoid? Like an electromagnet. Yeah, so they'll go like this. এখান থেকে বের হবে, টার্ন করতে হবে, টার্ন করে হচ্ছে ঘুরে আবার কি করবে? এদিকে ব্যাক করবে. That's typically it. আর টু ফ্লুইড হয় জিনিসটা। সো এখানে রিকোয়ারমেন্ট হচ্ছে যে অ্যারোস ফর এক্স ওয়াই জেড। এক্স এরটা কি হবে? Yeah, same এই ডাইরেকশনে। জেড এরটা কোন দিকে হবে? এক্স্যাক্টলি ফ্ল্যাট এন্ড অপোজিট। এটা ইম্পর্টেন্ট মাঝখানে। ওয়াইটা একটু ট্রিকি। ওয়াইটা ও লেভেল সো এক্স্যাক্ট কোয়েশ্চনটা ছিল। ওয়াইটা কোন দিকে হবে? স্ট্রেট উপরে কেন? Like vertically upwards, little bit tilted to the left, huh? Horizontally to the left. একটা অ্যাঙ্গেল করে কি যে এরকম এদিকে আচ্ছা with the field line. Yeah, so এখন হচ্ছে এটা বের করে একটা ওয়ে আছে কি করতে হয় you take a what compass, plotting compass, and plotting compassটাকে এখানে প্লেস করবা আর plotting compass এখানে প্লেস করার পরে যে ফিল্ডটা জেনারেট করবে ওইটাই হচ্ছে কম্পাসটার ডিরেকশনটা হবে রাইট সো দেখো যে এদিকে যেদিকে পয়েন্ট করে এবং কোশ্চেনটা হচ্ছে আমাদের তো এই plotting compass নাই neither do we have this solenoid right what I'm going to do here so এটার জন্য হচ্ছে তোমাদের মনে রাখতে হবে there's actually a diagram about this and diagram তো দেখাই তোমাদেরকে exact questionটা ও লেভেলসে ছিল most likely answer is vertically upwards okay that's a possibility I'll show you কি হয় এখানে So এটা visualize করতে problem হবে. We'll first see this animation and then দেখি যে আমরা কি figure out করতে পারি নাকি. So if you see here, this is a bar magnet, right? এটা হচ্ছে bar magnet, which is not a problem because our solenoid will produce the same thing, right? So আমি যদি হচ্ছে magnetic field গুলো এগুলো সব off করে দেই, and I take my plotting compass here. So right now it points this way. ভিতর দিকে গেল হচ্ছে উল্টা জায়গাটা, তারপর বাইরে এসে এদিকে আসলো. If I go up here, it points this way. But in the transition part, there's actually a point where which way does it point? Upwards. The problem is, a question ওইটা যেটা ওলা ছিল was very clear, or line দিয়েছিল. But a question where are we? Are we like, এই জায়গাটা তো বুঝলাম, but are we here? Are we there? Are we there? That's not really clear. So my indication is it should be something like this. Because এভাবেও হতে পারে if we're very close. But if you go further and further out, it starts to like straighten. আর এখানে এসে কি হয়ে যায়, উল্টা হয়ে যায়. এটাও it's fine, উপরের জায়গাটা, আর এটাও fine. But এই জায়গাটা is the one, দেখো straight হয়ে গেল. আমি বেশি দূরেও যাইনি, it just becomes straight like that. I'm not controlling this. The magnetic field is how so magnetic field এর মধ্যে রাখলে কি এরকম দেখতে হয়. So the question is, are we here or there or there? তিনটা different দেখবে, right? So let's get back to the question. So এখানে হচ্ছে where we এই জায়গাটা, right? I think if this was in the exam, I would probably have done this. কারণ আমার মনে হয় আর একটু টাইম লাগে হচ্ছে এই জিনিসকে ঘুরে ব্যাক করতে হলে, ওকে? বাট ওই যে ও লেভেল পেপারটার মধ্যে যেমন হচ্ছে এই জায়গাটা পার্টিকুলারলি আপ করতে দিয়েছিল, আর হচ্ছে কি হতে পারে, what did you guys say? Up, vertically up, to the left, slightly to the left, right? To the left, like this. To the left, so like that. Okay. What did you write? To the right. What was the answer? Left. Is there a left possible here? I don't think so. Because if you look at the diagram, this is it, right? I don't think there's like a location where you can go around this fully left, either vertical or to the right. No, that's the screen. So there's no place where you can go right. Left is possible. You said right. Because for right, you have to be like there, up there. Now, yes, again, it's subject. We can't really say. They didn't give any other option. Straight should be fine as well. I'll show you, like, the question that was straight. That the one that idea of how things can change. Because so many questions for us. I'll show you the question. Hey, look at this. এখানে কোয়েশ্চেনটা ছিল যে এই কম্পাসটা এরকম করে কোন দিকে পয়েন্ট করতেছে, where should the compass be placed so that it points like that? This is O level question, right? See, তো এখানে তো easy to predict because এটা এদিকে গিয়ে এভাবে যাচ্ছে, so it should be something like that. আর তো কোনো অপশন নাই. But the thing is, আমাদের কোয়েশ্চেনটা যেটা করছে যে the reverse part, মানে আমাদের কিন্তু কোনো জায়গা দেয় না, লাইনটাই আমরা ড্র করতেছি, কম্পাসটা আমরা বসাচ্ছি. So I think we should have more freedom in the answer. So I'm guessing maybe they will accept. Worst case scenario is that I think তোমারটা তো এখানে ছিল, this and that should be possible. This one is a bit unlikely because you can see the lines will have to go this way and then somewhere there you have to be pointing right. Okay, that was 4B. Do you have problems with the part 2? Okay. Slightly out. Like that? No. Because inside the coil, the lines are fully parallel. It's a uniform field. You can make the arrow bigger, smaller. Strength fluctuates, but not direction. Oh no! So what happens is it goes like this, right? Like it curves in, but inside they're all straight to each other because when they all emerge parallel to each other. Also, do you guys know that field lines have this very important limitation? They can't watch each other, cross each other. So if you have a line that's pointing that way, it has to cross some other line. That can't happen. Okay, so the lines should be in such a way that they can't interact or overlap with each other.
So in the center, all very close.
Yeah, very close. So they'll be like very close but parallel. So if your X is slightly pointing up, right, it will eventually have to cross to other lines. So did you point curve down or up? Yeah. But yeah, they'll start to bend outwards away from each other. But oh, did you point your arrow slightly down or up? Up. Oh, okay. I get it. So you're saying that it curves like that. No, the curving happens much earlier. Okay. Though, no, it's actually very uniform inside. The curving can happen here, like at the start and maybe slightly at the end, but not at the center. The center is very strong and very uniform. Okay, Bolo, which one? Next. 5B. Oh yes, Igla I really hope the exam answer, okay? Because Igla one of those questions Igla ji paro 4 marks for just drawing 3 lines. That's much better than writing a 100-word essay. So এখানে বলছে state Faraday's law of electronic induction. What does it state? যদি ভুলে যাও exam at least formula লেখো. What's the formula? First of all, ভুলবা না এটা ভুলার কিছু নাই তোমাদের পারতে হবে এটা 20 marks for definitions. I think minimum that you can do is get them minus n d phi by dt. D phi by dt problem is the differentiation, and as you know, calculus is not part of your syllabus, right? So a part of just keep over, you just say it in words. Rate of change of magnetic flux, okay, linkage. তারপর বলছে coil দেওয়া এখানে and everything. This shows a variation with time of the magnetic flux density in the iron bar. The voltmeter measures EMF V2 that's induced across coil 2. Coil 2. Achha. So it's a coil 1 voltage. Magnetic flux in the iron bar shows a variation. It's in the iron bar. Connected potential difference in V1, and V1 gives something V2. What is the V2 there? Okay, let me explain the question. The question is that we have a supply here, and let's say this is plus here, and that is minus, and your current will flow through this circuit, and current hypothetically speaking, okay? What will this produce around it? If there's a current passing through a coil, right? What does it generate around it? Magnetic field, right? So a magnetic field or electric field also give a magnetic field, right? So magnetic field produces, and this is an iron bar. So the iron bar will carry the magnetic field to the other side there, and the other coil will cut the magnetic field, and EMF will be induced, right? Does this ring any bell? There's a device that does this. Transformer. That's actually a transformer that they've designed here. Okay, it's just instead of those like this and that, we're doing like a pipe here. Okay, so transformers are requirement low, and this is a common question out there. They'll give you a question where they'll give you the input of a transformer voltage, and they'll ask you to draw the output of a transformer voltage. And in some years, it's 1 mark because it's a sine graph, and you have to figure out কি হবে এইটাতে যেহেতু ওরা গ্রাফ কিভাবে দিয়ে দিচ্ছে তোমাকে to figure out করতে হবে. So question for everyone, okay? This is the change in magnetic flux. How do I get EMF here? Tell me the sequence of events that takes me to my EMF. So first, say graph to আমি কি করব? Rate gradient, right? So this is B. I mean, I have to break down, but this is B, which is going to be proportional to the watt of the coil, phi. This B is what phi comes from, or phi comes from B. Now you have del B going on here. I'm going to change in B. That should be proportional to my watt, change in phi. And that means B differentiation যদি আমি করি যে টাইপের আউটপুট পাবো আমি phi এর differentiation করলে কি আউটপুট পাবো? সেম টাইপ পাবো. Because we can jump to that, and because we know in the back of our mind যেটাই হবে, but sometimes I'll ask you to explain that. তখন তোমাকে বলতে হবে the change in flux density will result in change in flux linkage, and rate of change of flux linkage is what will produce what induce EMF. So এখন এটাকে differentiate করলে আমরা EMF এর কাছে যাব, EMF তো পাবো না, কাছে যাব. So EMF is proportional to what? Change in phi by change in time. So I have to differentiate this, where you have to apply a bit of math knowledge. Can you tell me what kind of gradient is in this part of the line? Positive, right? So we'll have a positive gradient here. Select a random positive value নিলাম আমরা. তারপরে you have a negative gradient here, but then you have to look out for, is it steep or not? Because that's something they look for as well. Okay, so do you think that A line are same steepness, or do you think this one is steeper, right? So আমার হচ্ছে এটার ভ্যালুটা যাই হবে ওইটা থেকে এটা কি হবে, বেশি হবে. আবার হচ্ছে এটা পাচ্ছি এখানে, এখন আমি একটু দেখি নি if they're parallel or not. If they're parallel তার মানে ভ্যালুটা আবার কি হবে, same হবে, right? So they're parallel, which means we'll end up with what value here? Same. এটা কি প্লাস হবে না মাইনাস হবে? Plus, because we're looking at the gradient, it's a positive gradient, right? So this is supposed to be how the graph would have looked like if you found the differentiation of d phi by dt, but EMF is not the differentiation only. So what else is there? Huh? Right, so EMF is equal to minus d phi by dt. So আমার যেটা করতে হবে এটাকে উল্টা করে দিতে হবে, and that should be the graph. Right, ওটা 4 marks, so they'll check that. I mean, I'm making it to steeper. So yeah, do you understand this point that it doesn't have to be a subjective, right? You have to have values here because values are also, right? Let's see how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes up. আর এদিকে হচ্ছে 15 boxes, right? 15 boxes, right? আর এখানেও হচ্ছে 10 boxes and 15 boxes. So এই দুইটা ভ্যালু exactly same হবে, but এখানে you have 10 boxes and 1, 2, 3, 4, 5, 6, 10 boxes, না না এই যে এখান থেকে এখানে 10 boxes. No, I'm talking about x-axis. X-axis 10 boxes, হ্যাঁ, আর y-axis কত? 20 boxes. So obviously it's going to be greater. এইটা ছিল হচ্ছে 10 divided by 15 boxes. আর এটা কি হবে? 20 divided by 10 boxes. So obviously it is 0.67. ওটা হচ্ছে 2. So it's going to be like 3 times different. আচ্ছা, so এটা যদি হচ্ছে তুমি 3 নাও তাহলে ওটা 9 নিতে হবে. আচ্ছা, so এটা যদি 3 হয়, আমি বলি রেশিও করো তোমার যেভাবে. আচ্ছা, I think they do sometimes. Sometimes they even mention that it must go through this coordinate or this point, especially when there are graphs where the gradient increases. By how much it increases is something they look for. Well, yes, because sine graph যদি b হয়, d phi by dt হচ্ছে cosine হবে, minus cosine হবে. And একটা question আসে যে how are they shifted? 90 degree. So yeah, একটা transformer input and output is 90 degree phase shifted. The peak value, right? The RMS is not based on what kind of sinusoidal graph you have. It has to be sinusoidal graph, and it has to have a peak value. So VRMS is V peak by √2, but it is only valid for your graph in a sine or cosine graph, but doesn't need to be sine or cosine. You can choose it. Both are for কোনটা? 8B. Will absolutely have no impact on your magnetism. The only thing that will have impact is as long as whatever you place in the core is a conductor or ferrous. If it's ferrous, like iron, it'll improve the magnetism. If it's steel, it'll ruin the magnetism because steel has its own field that can oppose it. And if it's metal, A2 তে আসতে পারে metal. The metal হলে there's a problem. that if it's a metal and if there's a change in magnetic flux, the metal will have an induced EMF and it will produce its own field, which will oppose the original field. Yeah, so let this and weaken it. So if you ever want to use a solenoid, the only thing is to use iron core. It will just make it better. Rest of them are, questionable. Okay, 8B. Right. So say two situations in which charged particle in a magnetic field does not experience a force. When will a charged particle not experience a force? If it's stationary and if it's moving parallel to the field lines. Okay. Acha. এটা বলে রাখি আগে থেকে I have come across this question every single year. এটা একটু সামনে আছে. The one with the coils. Picture করতে problem. We'll try it. Okay. দেখো কি হয়. So আগে থেকে বলে রাখলাম this is difficult. So it says a loosely coiled metal spring is suspended from a fixed point. So একটা coil দেওয়া এখানে. Electrical connections are made to the ends of the spring by means of flexible lead. So lead গুলো দেওয়া আছে. The length of the spring is measured before the switch is closed and then again after the switch is closed. When the switch is closed, the magnetic field is set up around each coil of the spring. And just number তুমি কাটতে দিতে পারো হ্যাঁ বলে দোতলা দিয়ে আসছে Okay, it says by reference to these magnetic fields, explain why there's a change in the length of the spring. State whether it extends or contracts. So current যদি pass করে, what happens to the change in the length of the spring? So let's try to work through the process here. So first এটা plus হবে and এটা minus হবে. So current will go this way and current will go here. And current taking the ঘুরে, let's say the front face. আচ্ছা, so এটা front face, এটা front face. Do you follow? দুইটা যে current হয়ে যাচ্ছে এখন what will happen to the coils because of this? So যেটা করতে হবে, so do you think it's going to contract or expand? Contract. Why? Right. Anyone else? Any other? Okay, that's actually the right way. আমি কি করতে এখানে visualize করতে যে প্রবলেমটা হয় is students take the coil entirely, don't take it entirely, take it as individual loops and see what happens. So first loop টা যদি আমি দেখি, this is the front of the loop, okay, and this is also the front of the loop, and আমাদের যেটা হচ্ছে a back of the loop এর মধ্যে you have current going the other way. We'll just focus on the front. Do you guys remember how a field line looks like around a single coil of wire? We have seen this, right? So the right hand rule they use for like so in this coil, if the current in the front faces this way, right, coil can not pull because if I draw the field line for one single coil, right? This is part of your syllabus. We did this the other day. Our arrows point outwards, our arrows inwards. So the lower part of this solenoid will have a what pole? The lower part, south, right? South of it, and the upper part of the solenoid will have a what pole? North. But then this other solenoid will also be what? The same. So aren't there two opposite poles here? What would they do to each other? Attract, right? So what is it supposed to do? Contract. Okay, so the size will become smaller. I don't remember exactly what the issue was, but tomorrow to figure out because a couple of students had issue like where they took the whole thing as a magnet and they tried to think because they thought that this was actually a magnetic material or whatever thought process. So yeah, this is how you do it. So you look at individual coils and see how they interact with each other. So the question was for 4 marks, I think. By reference to magnetic fields, explain why there's a change in length of the spring, right? And state whether the spring extends or contracts, right? So how do you answer this though? না আমার বুঝলে তো হবে না, এক্সামিনারকে বুঝাতে হবে। So how do you write it in a way that they understand? Is that's what you need to be good at. So আমাকে কি পয়েন্টস গুলো বলো, কি বলবো ফার্স্টে? You have jumped to the end. তার আগে কি হলো? না ওই রিভার্স আর্গুমেন্ট দেওয়াটা একটু ট্রিকি, মানে আই থিঙ্ক সিকোয়েন্স ফলো করবে। Each other because opposite poles attract. So first point হবে, as current passes through the coil, there is a magnetic field generated around the coil or induced around the coil. Next point হচ্ছে, individual coils will have opposite poles facing each other between them. That's the important part. Individual coils will have opposite poles facing each other between, and opposite poles what each other attract each other. Each of the loops attract each other, so the whole thing what contracts. Okay. With the switch in B closed, a small mass on the free end of the spring is now made to oscillate vertically. Switch close করে, we make it oscillate vertically. With principles of electromagnetic induction, explain why small fluctuations in current in the spring are found to occur. Right. So তুমি যদি এই ব্যাটারিটাকে ক্লোজ করে you give it a small oscillation, দেখবে যে কারেন্টটা ফ্লাকচুয়েট করে। কেন? Magnetic field lines cut the coil, or coil cuts the magnetic field lines? It's a little different. Yes. So যেটা হচ্ছে ভিতরে the magnetic field আছে and the coil is moving within that field, so it's cutting its own field lines. So as a result, what will be induced in the coil? EMF, right? And that EMF will generate a what, because it's a closed loop, a current, and that current will cause fluctuations, right? Now, I don't know the 4 marks for the 3 marks. The same question was there in edX. Other question that chilo fluctuation the key type of, like, what kind of fluctuations? So the fluctuations are going to be like, cyclic or random. So they can graph draw with those, and the fluctuation will actually look like the oscillation. When oscillation J frequency the fluctuate করে ওইটাতে হচ্ছে current fluctuate করবে, and the reason is at one point of the oscillation the EMF will be induced that opposes the battery, কারণ উল্টা দিকে যাচ্ছে। আবার একটা জায়গায় এটা এভাবে ইনডিউস হবে that it actually assists the battery, so actually ব্যাটারি থেকে বেড়ে যাবে, তারপর কমে যাবে, and the midpoint will be the what, the current, the battery's original current. ঠিক আছে, আচ্ছা আমি বলি, so এই ব্যাটারিটা দিচ্ছে হচ্ছে let's say 5 ampere. Yeah, it's a sine graph. মানে it's a তোমাদের oscillation, simple harmonic motion এর যে গ্রাফগুলো, এই গ্রাফগুলো। So let's say this circuit gives you a current of 5 ampere. That is your what current? Base current. মানে কিছু হচ্ছে না 5 ampere. তুমি এটাকে টান দিয়ে ছেড়ে দাও, এটা অসিলেট করতেছে। Isn't it cutting the field lines? So একটা পয়েন্টে যখন উপরের দিকে যাচ্ছে, it cuts the field lines. EMF is induced, right? A current is produced to oppose the motion. Let's say তোমার কারেন্টটা, এই কারেন্ট যেটা ইনডিউস হচ্ছে আর what to each other, opposite. তো তোমার 5 ampere শো করবে না কমে যাবে? কমে যাবে। But the thing is, as it goes up, যদি কমে যায়, তাহলে নিচে নামলে তো আবার EMF induce হবে, আবার current generate হবে, but this time the current is going to be in which direction? The other direction, and it will assist your battery. So তোমার কারেন্টটা বেড়ে যাবে। কোথা থেকে বাড়বে? 5 থেকে। So তোমার যদি 5 থেকে 0.2 কমে, ওটা 5 থেকে 0.2 বাড়বে, and the graph was like a fluctuation with the mid baseline being 5 ampere. It's just ওদের আসলে দেখে similar একটা question, so তোমরা দিতে পারো। Okay. All right, Bolo, what's next? Do you want me to write the answer? Parva. In this answer, yeah, I think the Marskim wrote that. Yes, that was the issue that we had. Like students tried to use that. It is possible because magnetic field interactions between two parallel wires. Remember, if you have two wires parallel and there's a current passing through them, what do? They move towards each other, right? But how did we answer that? We answered it based on the field lines are opposite. They weaken at the center, they're stronger on the outside, right? But Cambridge actually doesn't prefer that way. They actually prefer that the field of this wire does what on that wire. So you could do that here as well. Though it becomes like unnecessarily complicated. So I'll show you what you need to do here. So you have to imagine that this wire here produces a water on it, magnetic field. And you have to take this magnetic field onto this part of the wire. And then this magnetic field, this current will generate what? A force. And that force would be downwards. And for this one, that force would be for that one upwards. When this one's one here would be upwards. So that will bring it closer. Or you could think about the one we did the other day, that two wires are parallel. Just in this diagram, ignore the back part. Just focus on the front part. So what's produced between the magnetic field? And at the center, the magnetic fields actually are opposite to each other, so they cancel out. And on the outside, they're stronger. So these two will get closer to each other. So there are many ways of approach here. The Marskim prefers the left-hand rule and they talk about it, which I feel like you could, but this is more intuitive. Part of the hierarchy. কি বলছিল? Use principles of evolutionary induction to question paper, magnetism. Which year? Question magnetism. But the magnetism question you told us from question paper, you can send it to me. Did you send it to me? তোমার তো আসে নাই আদিন তো আসছে June 4-3, so that's like 4-1. Is it here? I had 21 or paper with us. May, June 21. That's him. Put this there. Sorry, B. This one. I think everyone has this one. Define the Tesla. Okay, go ahead. 3 marks, that's a lot. 3% of your paper. Oh, what? Yes. When they say define a unit, all the quantities must be units. So Tesla ki hobe? It's the, so I think the better way is to say 1 Tesla is what? Do you understand what I'm trying to say here? So 1 Tesla is a magnetic flux density that generates a force of 1 Newton on a wire carrying 1 ampere current, having a length of 1 meter, such that they're all perpendicular to each other. That's the better way. Okay, because যখন ধরো unit বললে you have to talk about the units there. আরো যদি জিজ্ঞেস করতো what's magnetic flux density, তখন এটা answerটা different হতো। তখন কি হতো? It is magnetic flux density is when a unit length of wire carrying a unit amount of current in a unit magnetic field experiences a force of what? A unit force. That's it. ওখানে তোমার ইউনিটের নিউটন বলতে হবে না, এখানে তো নিউটন বলতে হবে। বলো কোয়েশ্চন ছিল কার? হ্যাঁ পারবা, মানে এই ফর্মুলাটা b equals to f I by sorry f equals to BIL, b equals to f by IL, হ্যাঁ হ্যাঁ ওটা করতে পারো, বাট ওই যে ইউনিট বলতে হবে। আচ্ছা, the magnet produces তোমার মনে হয় নেট বন্ধ হয়ে গেছে, আমার আসে নাই, হাফ হয়ে এসে ক্যান্সেল হয়ে গেছে যেটা সেন্ট হয়েছে। I've seen the message. What? No. এই যে এখন আসছে। Arika, did you send it right now নাকি আগে? আগে। আচ্ছা, the one with the box. I explain why electrons do not continuously accumulate at the face. ওইটা আচ্ছা। আচ্ছা, এটা quickly answer করে আসি because I discussed this the other day. এখানে I'll add it here. Okay, look at this. It says rectangular face of piece of aluminum is in a magnetic field and everything. The magnetic field is normal. Now I can electrons of charge q enter the foil at right angles at the face p, q, t, v. On figure 9.1, shade the face on the foil where the electrons initially accumulate. Right, initially accumulate. So remember what we talked about this, initially হয় পরে balance হয়. So কেউ কি আমাকে answer করতে পারবে যে এটা দেখে initially কেন excited যায়? Yeah, because there's a net magnetic field. So the net magnetic field, if you use the left-hand rule and reverse it, you'll get your answer. So in this case, this is the movement of your electrons, right? So FBI, current is going that way, magnetic flux is downwards. So they're supposed to go which way? ADK, the front face, right? So they accumulate on this side. So you'll find that the charges will be here, sorry, ADK. Is that okay with everyone? আচ্ছা, পরের কোয়েশ্চেনটা বলছে maybe 3 marks, I don't know কত marks. Explain why electrons do not continuously accumulate on the face you have shaded. It's a very important question. কেন? Sorry? Right, why is there an electric force? Because of the electrons, right? So what happens is the electrons come to this side, right? And as the electrons move this side, the other side has less electrons. So the other side is more what? Positive. And between 2 plates, when you have negative and positive, right? What's generated? 2 plates plus and minus, right? What is generated in that region? An electric field, right? And the electric field is going to act which way on the electron? Towards this face or towards the other face? Other face, right? So what will happen? The electrons will start to do this. And as they're doing this, at one point, they'll start to move that side, because who's taking them that side? The electric field. But as they start to go that way, isn't the electric field getting weaker? Because the electrons are moving away. So at one point, they'll attain what? Equilibrium. That's when you get the Hall voltage. So the thing is that you that side, because we're using left hand, and left hand is for positive charges. This is an electron. So the whatever. Yeah. So FBI. If I use my left hand, right, what is I? direction of positive charge. The left hand is for the positive charge. Okay, and then I have taken it in the direction of the electrons. Okay, so now whatever my answer would be then has to be reversed, because I've done the opposite. Or you could have taken a right hand, but I don't prefer using that many things. Always use a left hand. If it's positive, it's your answer. If it's negative, just reverse the answer.
So this is such a question.
If you add unnecessary details. Oh, it's fine. So I'll explain what can you write. You can write things that are neutral. Neutral মানে কি? They don't have any relevance in your answer. So কিছু একটা লিখলা যেটা wrong না, but এখানে কোনো দরকার নাই, mark কাটবে না. But yeah, but if you write something that is like wrong and extra, and it's not relevant here, but wrong like so the magnets are fluids, right? Mark কাটবে ওরা, করার কিছু নাই. So whenever you write extra, just be sure that that extra is right. আমি সামটাইমস এনকারেজ করি এক্সট্রা লিখতে। আগে যেমন হচ্ছে ও লেভেলস আই সে নেভার রাইট এক্সট্রা, বাট এ লেভেলস এক্সট্রা কেন বলি, বিকজ সামটাইমস আই ফিল লাইক তুমি অ্যান্সার লিখলা এন্ড ইউ ডিডন্ট রাইট দি এক্সট্রা থিঙ্কিং যে এত লাগবে না, পরে দেখা গেল মার্কস স্কিম ওইটাই চাচ্ছিল ওরা, এন্ড ইউ ডিডন্ট রাইট ইট বিকজ ইউ ফেল্ট লাইক এত দরকার নাই, বিকজ দ্য মার্কস স্কিম দ্য ওয়ে দেয়ার মার্কিং নাউডেজ দে ভেরি লিমিটেড। হ্যাঁ, মানে জাস্ট ওই তিনটা দিয়ে আর কিছু বলে না ওরা। সো I feel you should write extra, but be sure that you know this is right. It's just you feel like maybe it can relevant now, but I think maybe it could be possible. Just add it. Okay. Yes, it should. Now, I'm Cambridge at the problem. I'm Cambridge check papers below. Because students normally don't get them. edX don't check papers below. I notice they don't give marks. রিভার্স আর্গুমেন্ট একদমই দেয় না। সো যে প্রজেক্টাইল মোশনের কোয়েশ্চেন একটা এক্সাম্পল বলি, যে একটা পার্টিকেল যাচ্ছে, এটা রেঞ্জটা কত, মানে রেঞ্জটা কি অ্যাকচুয়ালি এনাফ নাকি কোয়েশ্চেনটা, যে ডাজ ইট অ্যাকচুয়ালি ফল এট দ্যাট প্লেস অর নট, হাউ ডু ইউ ডু দ্য ম্যাথ এসে ইউ ফাইন্ড ইওর রেঞ্জ, আর তোমার রেঞ্জের থেকে বেশি নাকি কম ওটা অ্যান্সার হবে, রাইট? বাট সাম স্টুডেন্টস ডু দি আদার থিং, ওরা কি করে, ওরা টাইম বের করে, এন্ড টাইম বেশি না কম দেওয়া এক্সপ্লেইন করা যায়, অ্যাকসেপ্ট করে না, দো ইটস পারফেক্টলি লজিক্যাল। You are getting the same answer. You're just referring to the fact that because the time taken should be longer, it must have crossed that range, right? Or an anoida. So this is, I know, because edX check scripts are so are accept for now. So when you to talk about is the range enough or not, you have to talk about if the range is enough or not. Right. So you get to the it says a magnet produces a uniform magnetic field flux B in the space between its poles. Rigid copper wire, and everything. Okay, the balance the weight W on the other side. The section of the wire between the poles is provided here. Explain why section QL of the wire give rise to a moment above the pivot. QL current কোন দিক থেকে আসছে? Current হচ্ছে এইখানে এন্টার করতেছে here and in the যাচ্ছে, right? So current QL যাচ্ছে. How do you find the force FBI? Not to south, force কোন দিকে হচ্ছে? নিচের দিকে। So এই ফোর্সটা মোমেন্ট জেনারেট করবে। Yes, because আমার রডটা এরকম দেখতে না, আর ধরো যে এখানে পিভটটা যে এরকম করে দেওয়া, right? So wouldn't this downward force here produce a moment? What moment? Anti-clockwise, right? তোমরা কি বুঝছো? ডায়াগ্রামটা বুঝো নাই কেন? কি প্রবলেম? এই যে এখানে হচ্ছে আমি যদি এই জিনিসটাকে নিচে টান দিই, I hold this with my hand and I pull it down. Will it rotate? This is the pivot. Yes. The magnet do the force that can rotate করবে না. Why will it go anti-clockwise? Yeah, anti-clockwise like this, right? বুঝছো তো? Okay. Next হচ্ছে, so question কি ছিল 3 marks এর জন্য? Right. How do you write this answer? So you said that the current in the wire QL produces a what around it? A magnetic field that interacts with the magnetic field of the magnet, and as a result of what is generated, a force. And যেহেতু ওরা চাচ্ছে, you have to say the force in direction, which is which way? Downwards, right? Then you say the force is perpendicular to the distance from the pivot, and as a consequence, what is generated? Moment. So momenটের জন্য যে force perpendicular করতে হবে, ওটা I think acknowledge করা দরকার. Okay. তারপর বলছে the section PQ and LM of the wire do not affect the equilibrium of the wire. কেন? Because এইখানে কারেন্ট হচ্ছে, আবার এইখানেও কারেন্ট হচ্ছে, উল্টা দিকে। Now if I find the force here FBI, force হচ্ছে outwards আর এদিকে force হবে এদিকে, and these forces are acting in opposite direction, number one, so they will cancel out. On top of that, they're acting what to the pivot? Parallel. মানে আমার pivot এখানে force তো এখানে, so there's no moment acting this way. Momenটের জন্য তো perpendicular হতে হবে. You get my point? So therefore there's no net moment generated. Okay, let's see. এটা ছিল নাকি পরের পার্টি প্রবলেম? আচ্ছা, NB3. Okay, it says a stiff metal wire is used to form a rectangular frame 6x8, and the frame is open at the top, and suspended from a sensitive Newton meter. Achha, the open ends of the frame are connected to a power supply, and everything is given here. The frame is slowly lowered into a uniform magnetic field. This is the front top view of it. Achha. When the side PQ of the frame enters the magnetic field, a reading on the Newton meter changes by 1 millinewton. Determine the magnetic flux density. Yeah, so যেটা করবো আমরা, your problem is in B3. আচ্ছা, আমি পুরোটাই করি। So এখানে হচ্ছে ম্যাগনেটিক ফ্লাক্সে এরকম দেখতে হবে, বিকজ আমরা কোন কম্পোনেন্ট নিয়ে কাজ করব, the perpendicular one, আর কারেন্টটা ফ্লো করবে, ওরা কি বলছে, current is 5 ampere, which is going from P to Q, so the current is going to go that way. Can you tell me which way is force going to be generated on this wire? FBI, current is P to Q, magnetic flux is that way, so the force is upwards. Upwards মানে পুরো কয়েলটা হচ্ছে BI upwards, কয়েলটা উপর দিকে মুভ করবে, so FBI, current এদিকে, magnetic flux is this way, force উপর দিকে। হ্যাঁ, ফ্লাক্স উপরে। আচ্ছা, বুঝছি। হ্যাঁ, না, we are actually doing the same thing. তোমার ওয়ারটা কি স্ক্রিন থেকে বের হচ্ছে? হ্যাঁ, ঠিক আছে। So আমি বলছি it's coming towards us, মানে স্ক্রিনের উপরে, মানে কয়েলটা উপরে যাচ্ছে। আমি বুঝেছি, I understand the confusion. এই যে কয়েলটা অ্যাকচুয়ালি এরকম দেখতে, P and Q 3D তে যদি দেখি আমরা, so এই যে like that, and ম্যাগনেটিক ফ্লাক্সটা হচ্ছে এরকম দেখতে, যেটা আমি ড্র করছি, আর এটা হচ্ছে P, এটা হচ্ছে Q, আর নিউটন মিটারটা কোথায়? এই উপরে, so Newton meter is there, and the current is this way. This is current, this is magnetic flux. Tell me which way the force is acting now. এইটার মধ্যে upwards, right? So এদিকে upwards হচ্ছে, so তোমার নিউটন মিটারের মধ্যে একটা চেঞ্জ বলছে ওরা, কিন্তু ওরা বলে না কিন্তু কি চেঞ্জ, জাস্ট বলছে changes by that. So ওয়েটটা কমার কথা, because it's going up slightly, right? So it's supposed to be lighter by that, and this force is 1 millinewton. Yeah, 1 millinewton. এখন ম্যাগনেটিক ফ্লাক্স ডেনসিটি বের করতে বলছে। হাউ ডু ইউ ডু দিস? এটা 50 হলে এটা 50, তাহলে এটা B sin 50, so F equals to BIL sin 50. F টা কত? 1 into 10 to the power minus 3, B টা unknown, কারেন্ট হচ্ছে 5, into length of this segment is how much? 6 centimeters. So 6 divided by 100 into sine 50. এটা করলে আসে, I think, right? So কত আসে এটা? 4.4. State with a reason whether the change in the reading on the Newton meter is increase or decrease. And reason কি হবে? Because the force acts upwards, or whenever you say force, you also have to say how you got your answer. Using what? Fleming's left hand rule. Sometimes they say like it, sometimes they don't. So I think it's safer to always mention it. So কেন যে উপর দিকে তোমাকে তো বলতে হবে using the Fleming's left hand rule. The frame is lowered further so that the vertical side starts to enter the magnetic field. Suggest what effect this will have on the frame. The vertical ones start to enter the field. Vertical one. There's two sides, right? So তাহলে কি হবে দেখি, এটা আমার যদি ওয়াইডটা হয়, এখানে কারেন্টটা কোন দিকে অ্যাক্ট করতেছে? নিচের দিকে। So FBI current is magnetic. Shouldn't be any effect because I think the forces act in the horizontal direction and towards each other, so they cancel each other out. Rotates. বুঝছি। আমি just একটু দেখুন FBI currently first. Right. যেটা হচ্ছে the force is not only one of them. আমরা যেটা use করছিলাম, we use which component to find the force here? The vertical component. Doesn't this magnetic field also have a horizontal component? Right? And wouldn't that also interact with the wire? কারণ আমি যদি ওয়্যারটাকে এখানে নোটিস করো, এই ওয়্যারটা কিন্তু there are two fields of একটা এটা, আবার এদিকে একটা কি field হবে, এদিকেও হবে. Both of these fields are what to the current in the wire, perpendicular. So both of them will generate what? A force. And that force is going to be in a particular direction. And directionটা কোন দিকে হবে ওটা একটু বের করে দাও। I think এদিকে হবে। So এটা ওই সাইডেরটা ওইদিকে হবে at an angle of 50 degrees. কারণ আমার পুরো জিনিসটা শিফট হয়ে যাচ্ছে। So it should rotate. Did they say which way it rotates? No. Anti-clockwise দেখাচ্ছে আমার এখানে। আচ্ছা, আমি তোমাদেরকে একটু এক্সপ্লেন করি what I said earlier and কি হবে actually answerটা। So এটা হচ্ছে top view of the coil, okay? আর যে you're looking at the coil from the top, এখানে current is going into the page. বুঝছো কেন into the page? Because এই top থেকে যদি দেখো এই সাইডে, I'm looking from here, isn't the current going into the page? And isn't the current coming out of the page here? So এই সাইডে হচ্ছে current is coming out of the page. Like on that side. এখন এখানে যদি হচ্ছে ম্যাগনেটিক ফিল্ডটা প্রোভাইড করি like this, তোমরা ফিগার আউট করতে পারবা। Look at this, okay? This is my magnetic field. এরকম। Can you tell me which way is force acting on this wire? So আমরা যেটা করব, we'll first break down this magnetic field into what? Two components. একটা হচ্ছে এটা, which is going to be my what component? Horizontal component. And find the force because of that. একটু বের করবা, এটা যদি আমার ম্যাগনেটিক ফ্লাক্সটা হয়, which way is your current going to flow? Sorry, force কোন দিকে হবে? এটা যদি B হয় আর কারেন্ট এখানে কি হচ্ছে into the page, which way is force? FBI, current is into the page, magnetic flux is this way, force is এভাবে, right? আচ্ছা, এখন there's another component out there. Which component? The vertical component. So let's take the vertical component here. So vertical component যদি এদিকে নিই আমরা, এটার জন্য কোন দিকে হচ্ছে ফোর্স হবে? FBI, current this way. না, to the right. হ্যাঁ, to the right, exactly. So to the right এদিকে একটা ফোর্স হবে। হ্যাঁ, তাহলে যেটা বলছো ওইটাই হবে। So to the right হবে। এখন আমি তোমাদেরকে যখন ফার্স্ট অ্যান্সার বলছিলাম, I only considered the A ফোর্সটা। So আমার মনে হয়েছিল এটা যেহেতু লেফটে আর ওটা যদি রাইটে, এটা যদি কয়েলে অ্যাক্ট করে কিছু হবে না। But because of this force and that force, what's the resultant look going to look like? Something like this on this side of the wire, and something like that on which side of the wire? That side of the wire. So what will it do? Rotate, okay, anti-clockwise way. I think for 1 mark it's too much work. And figure this out. Yeah, suggest যেতে বলছে আর কিছু বলে নাই, সাজেস্টে তো অনেক কিছু বলে. Yeah, so it keeps rotating until it's perpendicular, right? তোমার আমি দেখে আসবো. Yeah, I'll on Monday I'll be doing like all the P5 mock papers together. আচ্ছা, or radioactivity হচ্ছে radioactivity quantum physics medical physics হচ্ছে কোয়েশ্চন পেপার থেকে আমরা করব. কোয়েশ্চন পেপার যখন প্রবলেমগুলো হ্যাঁ বাইনারি এনার্জি কিছু ইস্যু হয় যে অ্যাড করবা না সাবট্রাক্ট করবা ডিফারেন্স. Yeah.
I'm still kind of unsure on the spring of the mass. If both coils are going this way, like based on horizontal, if they're both going to the right, are they going on each other?
In this one?
Yeah, because they're spinning. One side is going this way, the other side is going.
Yes, exactly. So what will happen is this one's magnetic field here is going to be, let's say, into the page. That one's is going to be out of the page. They cancel each other out.
Cancel each other.
Yeah, because they're in opposite direction. So this place becomes a what field? A weak field. And there's an idea that force is always generated from the strong to the weaker side. So that's why they both try to move towards each other. আচ্ছা, তোমার এটাতে কোথায় প্রবলেম? The axle and rim are connected into an external circuit that enables energy of the rotation to be stored for future use. Use Lenz's law to determine whether the current in the disc is from the rim to the axle or the axle to the rim. Rim to the axle or axle to the rim. Right, so এখানে হচ্ছে magnetic field. So আমরা এটাকে একটা ওয়্যার হিসেবে কনসিডার করব. ওয়্যারের উপরে ফোর্স হচ্ছে এদিকে, ম্যাগনেটিক ফিল্ডটা হচ্ছে এদিকে, and অ্যাঙ্গেল গুলো হচ্ছে 90 ডিগ্রি, এটা আর হচ্ছে এটা 90 ডিগ্রি. বুঝছো কি করছি? এটা এভাবে রোটেট করতেছে না. সো আমি জাস্ট কি করবো, একটা পার্টিকুলার পয়েন্টকে ফোকাস করবো. এই উপরের পয়েন্টটা কোন দিকে যাচ্ছে? ওইদিকে যাচ্ছে. সো আই ক্যান সে দ্য উপরের পয়েন্ট ইজ horizontally going that way, and the magnetic field is this way. So this magnetic field has been cut by that motion. And আমার যদি magnetic field এরকম দেখতে হয়, কয়েকটা এটা এভাবে ঘুরতেছে, রাইট? উপরের পয়েন্টে কি এভাবে যাচ্ছে? So I can say this, right? So if this is my magnetic field, this is my movement, which would my induced current be? So right hand use for because this is induction, right? So I'm left hand করি F B I, B হচ্ছে F is that way, B is this way, current is upwards. The induced current is going to be pointing which way? Downwards. And question বলছে যে which way is the current flowing? It's going to be rim to axle.
Like, what are they doing like in the Western?
এটা হচ্ছে যে গাড়ির টায়ার ইউজ করা হয়. It's regenerative braking বলে. So যেটা করা হয় যে গাড়ির টায়ারের মধ্যে they place this kind of aluminum disc. So তুমি যখন গাড়ি হচ্ছে ব্রেক প্রেস করো, এই ডিস্কটা কি করে হচ্ছে টায়ারের কাছে চলে আসে. টায়ারের ভিতরে একটা ম্যাগনেট থাকে. So টায়ারের যে ম্যাগনেটিক ফিল্ড লাইন গুলো আছে ওগুলো হচ্ছে কাট হচ্ছে, and ওটা কাটিংয়ের জন্য যেটা হচ্ছে the energy, do you understand when field lines have been cut, EMF is induced? It's actually an energy conversion. which energy to which energy.
Magnetic.
না জেনারেটরে এনার্জি ট্রান্সফার কি হয়?
Oh, mechanical. No, mechanical to electric.
হ্যাঁ, so আমরা কি করছি গাড়ি মেকানিক্যাল এনার্জিটাকে নিয়ে নিচ্ছি আর এখানে কি প্রডিউস হচ্ছে টায়ারের মধ্যে ইলেকট্রিক্যাল এনার্জি। তো ইলেকট্রিক্যাল এনার্জি গুলো কি করে এই সব পার্টস অফ দ্য হুইল থেকে কিউমুলেটিভ ভাবে কম্বাইন হয়ে কোথায় আসে? মাঝখানে আসে। এন্ড ওরা কি করে এই তারটা ইউজ করে দে সেন্ড ইট টু আ ব্যাটারি এন্ড ব্যাটারিতে ইলেকট্রিসিটি চলে যায়, ব্যাটারিটা চার্জ হয়। সো এভরি টাইম ইউ ওয়ান্ট টু স্টপ আ কার হোয়াট ইউ ডু ইজ তোমার টায়ার রোটেট হচ্ছে, টায়ারের মধ্যে অ্যালুমিনিয়াম ডিস্কটা আছে, এই ম্যাগনেটটা কাছে চলে আসে। ব্রেক চাপা দিলে নরমালি আসলে ধরে যাবে, বাট এখানে কি হয় একটা ডিস্ক কাছে আসে, ওই ডিস্কের মধ্যে হচ্ছে ওর ম্যাগনেট কাছে আসে, ম্যাগনেট ফিল্ড গুলো কাট হচ্ছে, ইএমএফ ইন্ডিউস হচ্ছে। ইএমএফ তো আসতে হবে ফ্রম সামওয়্যার। সো কোথা থেকে ওই ইএমএফটা আসতেছে? ফ্রম দ্য লস ইন দ্য ওয়াট অফ দ্য কার, কাইনেটিক এনার্জি অফ দ্য কার। তার জন্য এটাকে বলা হয় হচ্ছে ইলেকট্রোম্যাগনেটিক ব্রেকিং or রিজেনারেটেড ব্রেকিং। কেন রিজেনারেটেড বলা হয়? বিকজ তোমার কাইনেটিক এনার্জি লস হয়ে যাচ্ছে, বাট ইউ আর কিপিং ইট অ্যান্ড স্টোরিং ইট ইন দ্য ফর্ম অফ ওয়াট? ইলেকট্রিসিটি। সো নরমালি যেটা হয় না, নরমাল কার এই যখন চলে যায়, where does it go?
The friction.
And it goes where? Heat, it's gone forever. এখানে এটা না, এখানে up to 60% হচ্ছে রিজেন হয়। বলো তোমারটা। এটা কি পেপার 5 ছিল? আর তোমার লাস্ট ক্লাসে একটা প্রবলেম ছিল, এটা ক্লারিফাইড। হ্যাঁ, ওটা কি অন্য ভ্যালুতে ট্রাই করছিল?